Okay, everyone, we are back after spring break. I am certain everyone enjoyed, even if we were still stuck at home, we still enjoyed just the peace and quiet and hopefully stress free week that you all should have had. If you could, please say hi in the chat so I know who's with us today. I'm enjoying being back, but it is still weird talking to a computer screen. Hey guys, it's weird, I'm sure, for you guys to get started after spring break. It's very weird for me. I definitely wanted to be back in the classroom with everyone. So what I've prepared this week is to get a slow start into good afternoon. Good afternoon. Hello, all. I want to get a slow start into our week after spring break. Again, just make sure that if you have not turned in your 7.2 through 7.5 skills practice, please continue to do so. It's definitely due today, but I wanted to make sure that we all do know that my grades need to be started to get into the computer by Friday, so there's still some wiggle room. So please just continue to check Google Classroom. I am truly trying to make sure that I update things regularly, and I will continue to remind you what is and is not required. So just keep reading, and hopefully we'll all be a little bit more comfortable as we go on. So right now, I have designed for you a really, really good review of what will be your Similarity chapter assessment. Okay, it is going to be your test. We talked about we were going to do our test after spring break. So to kind of get us back into the groove, I know many of you are turning in your 7.2 through 7.5 assignment. Thankfully, I see there's a big jump between yesterday and today, so I appreciate that. So what I wanted to do was there's 7 questions that I am going to go over. They are really close to what you're going to see on your test. I'm going to post these questions with the answers, obviously, after we're all done. And then I am going to post your test with the directions and then let you know what that deadline is as well. So with that being said, I did want to go over the first 2 questions that goes way back to the beginning of the chapter. In fact, those of you that even did the no reassignment right away, you didn't wait to put that off, you found that the proportions were very much the same as the multiple worksheets that we did, which now, due to this shutdown situation, seems like forever ago when we first introduced it. So right now we have our proportions, and this first one we do want to remind everyone that when we solve a proportion we are going to cross multiply, and in doing so we go through that equal sign. What we have to remember is when we cross multiply, that equal sign still has to show up. So you can even see when I'm doing my work, I'm lining up my equal sign. 18 times 10 is 180, and when I solve my proportion, this is when the division happens, because this does say 3 times x. We're going to divide both sides by 3, and we end up with x equals 60. So yes, this question is supposed to be easy. I'm not trying to pull any punches. I want to make sure that if we can solve a proportion, we can always solve a proportion. We don't have to worry about any, tricks. In the next problem, though, you can see that we have, again, they look the same, but when we cross multiply, we have to remember when you multiply a variable by itself, that it's going to change the power of the variable. So x times x is actually x squared, and then our equal sign still lines up, and 4 times 9 is 36. To undo a square, we do its opposite operation, its inverse operation. So we are going to take the square root. Now, here is where we had some issues right away when we did our worksheets. And then again, some of us found those issues during the no-read questions because we couldn't figure out why we weren't getting it right. And it's this idea that in geometry, we have a tendency to forget that there are 2 answers for the square root of 36. 6 times 6 is 36. So a lot of times we just write down 6 and we're like, yay, it's done. On one of my worksheets, right before, the week before we went on the shutdown, I even told everyone, you have to remember there's more than one answer here. 6 times 6 is 36, but so is negative 6 times negative 6. A negative times a negative is a positive. So when we write that answer, we write it as plus or minus 6. And what that translates into is x could be 6 or x could be negative 6. So it's that positive and negative situation. So that's really what that plus or minus is telling us. And again, we should have taken that from Algebra 1. But again, it's a subtle reminder because we have to have that for geometry as well. So first part of your test, you're going to have to remember how to solve proportions. So then we move into the second part of your test. And truthfully, it is reading the directions. We have to make sure that we read directions, that we don't forget that a lot of times in geometry, they tell us everything we need to know right in the directions. Again, some of us, when we got to our no-read problems, couldn't figure out why we weren't getting some of the stuff correct. And it was because we wouldn't put the segment bar. We wouldn't click on that icon to talk about segments. Or if we started doing the segments, we were forgetting that when it doesn't have the segment bar, it specifically means the length of AB, so a number, or the length of BC. So in here it says the given information, and I know I kind of crammed that in here, says that the length of AB over the length of BC will be equal to the length of ED over the length of DC. So this ratio will equal this ratio. And in turn, we can use that proportion to help solve for ED. So what I want to do is I want to use this proportion to fill in all of the work and all of the numbers. So the length of AB is going to be 3. The length of BC is 9, so there's AB over BC. We put our equal sign, then it says the length of ED. Well, there's nothing here for the length of ED, so we're just going to leave it as ED. And the length of DC is 12. So now, just like before, where it was just solve the proportion, we now have our proportion to cross multiply and solve. So we are going to cross multiply 9 times ED, and we put our equal sign, and then we cross multiply in the other direction, 3 times 12, which would be, 36. I said 12 and started to write a 2. Now to solve, we have to divide away our 9, and we end up with the length of ED is 4. Now, that's all the question asked us to do, so we're done. But if we wanted to, we could always check if, in fact, this is 4 to 12, 3 to 9. One of the things that we practiced at length in our videos, and then again in the no reassignment, is we were told if the ratio of the sides here that are divided, 3 to 9, 4 to 12, are the same, so 1/3, 1/3, it makes these segments, does anybody know what that makes these segments? If again, 3 to 9, 4 to 12, what happens to these two segments because we found their ratios were the same? Perfect. Thank you very much. And you used the symbol very well. Very good, Caitlin. We have, since these ratios are the same across the sides, again, we don't care what the length of AE and BD are. What we are able to figure out is that the segment AE is parallel to the segment BD. So this, again, isn't part of the question, but it could be. It could be something that, if necessary, we were able to work with and then conclude, because we did figure out that those ratios matched. For this question, ED was all it wanted. So again, I'm just kind of using what we have as information. And yes, it is because, Jacob, they do both reduce to 1/3 that allows that to happen. Again, I know nothing of AE and BD lengthwise. I do know, because the sides both reduce to 1/3, that they are parallel. Nice job. So again, we have proportions that we're going to have to make sure we know. We're going to have to read directions, and we're going to have to make sure we can fill in our information. We also want to make sure that with that information, we want to consider, what do we know that we've learned, so that we can make sure we have all of our concepts under control as we go through. So now we're going to switch gears, and we are going to now look at information. So right here, LMNO is similar to RSTU. What this allows me to know is that whatever my picture is, I don't care how awful the picture is, I don't care what I'm going to assume the picture is going to do. What I want to do is strictly use what's given to me here. So in order to kind of help with this, I'm going to work the problem out again on a separate sheet of paper, so that we can kind of keep track of all of this work, because some of you are still cramming a lot of stuff into a little bit of space. So I'm going to redraw LMNO, YW3 and 3.5. I'm going to redraw. Ooh, my marker's starting to run out. That's sad. RSTU. We have 7, 6, 10, and X. All right. So the fact that our given statement in number 4 tells us, so in our directions, it tells us LMNO is similar to RSTU. So here's the question that we're essentially dealing with. I want to use this, and whether I have to or not, I want to make sure that I use this information to write my proportionality statement. LM, first two, should be in proportion with RS. Those are corresponding segments. MN, that segment corresponds with ST. NO corresponds with TU. And first and last. And I didn't look at these two pictures when I wrote this out. I looked strictly at this. I don't want to look at my pictures, because I don't want to get caught up with, what if this one was turned one way and this one was turned another way, or it started LMNO and up here was RS, T, and U. So I want to be careful that my statement is how I make the proportion, not how the pictures are what's called orientated, how they're turned or drawn. So I use just this statement to write up this. So now when I plug in my information, I want to look at what is the length of LM, and it tells me it's W, and the length of RS is 7. MN is 3, and ST is 6. NO is 3.5, and TU is X. LO is Y, and RU is 10. So again, all of these mean the length of, without the bar, so the length of LM, the length of RS, and I plugged all that in. So I am certain that we can all recognize that right now, this is the only one that can give me an actual reduced fraction, a ratio. And that would be 1 to 2. Again, LMNO was on top, RSTU was on the bottom, so it's a 1 to 2 relationship when we're looking at this. Now this is going to help me because the first question said, what's the scale factor? So when I look back to here, the scale factor of LMNO to RSTU pretty much tells me it's 1 to 2. So we're going to say 1 to 2. Now, you could say 1 to 2, you could say 1/2, you could say 1, the word 2, and 2. Now, what I want to point out is what if it would have said RSTU to LMNO? What if it would have said find the scale factor of RSTU to LMNO? How would I write that? Good. It would absolutely be. Thank you, Morgan. I appreciate that. It would be 2 to 1 because, again, RSTU was the bigger one. LMNN is 1, is the smaller one. So I want to make sure that I have that. So now I can do, again, my work over here for part B. Here was our part A. Our 4B tells me let's figure out what WXY is. Now, most of us, probably with the way it was already set up here, can already tell me what WX and Y are already going to be because 1 to 2 is a pretty easy ratio. However, I can use my scale factor in each of these if I don't want to trust my gut, or kind of like me, we still check our calculator to make sure 2 times 3 is still 6. We know 2 times 3 is 6, but we still check it. So I can go through and use my scale factor to set up each of these proportions to cross multiply and solve. So 2 times W will equal 1 times 7. And we find out when we divide, W is 3.5. Over here, when we cross multiply, 1 times X is X, and this would turn into 7. And then 2Y equals 10, so Y is 5. And so we found each of these by using our scale factor to set up the proportions. So again, I showed my work. I can look here for W is 3.5, X is 7, and Y is 5. Now, because I know that, if I need to, I can come back into my problem and excuse me. I saw Elizabeth put hi from Matt and I got all choked up. Tell Matt I said hey. Ooh, gonna sneeze again. All right, so now I labeled this specifically because the next one says, what's the ratio of the perimeters? So I have to add these guys up. So for part C, LMNO has 3 plus we have 6 oops and now it asks us what's the ratio of the perimeter. Well, LMNO is 15, RSTU is 30, and we find out that the ratio, again, reduced to add everything up. But what we're supposed to remember is in one of our lessons we talked about that perimeter is just linear. It's the same thing as the lengths of the sides. So if we already knew what the scale factor was for the picture, any of the individual sides, 1 to 2, 1 to 2, 1 to 2, our perimeter has the exact same ratio. Now we did talk as a side note, because again, I'm just kind of reviewing, that we said the ratio of the sides is equal to the ratio of the perimeter. So we just saw that. That was a 1 to 2, 1 to 2. We did talk, and I did ask, and you can go back and look through our notes or our videos, that we said if we're going to talk now about area, the ratio of the areas, we have to do something to the ratio of the sides. Because now we're not just talking about adding everything up and keeping a linear measurement. Now with area, like in this case, maybe it was something like base times height or 1/2 base times height. But with area, we always have multiplication. So does anybody remember what we're supposed to do with the ratio of the sides in order for it to be the same as area? Remember, area kind of gives us a little bit of a hint. The other way to kind of remind ourselves what we're supposed to do is when we label anything with perimeter, it's feet, centimeters, miles, meters. We don't do anything to the label. We leave it as is. But when we talk about area, we always do area inches squared, feet squared, meters squared. So we always have something that's squared. And the same idea with volume. Volume, we're now taking a 3-dimensional shape and filling it. So we want to know how much of that 3 dimensions is affected. So with volume, we talk about inches cubed, centimeters cubed, feet cubed. So what do you think we're going to have to do to the ratio of the sides in order for it to be area, to match the area? Doesn't look like anybody remembers, so this is a good thing to have reviewed. You have to square the sides. So the ratio that we have for the sides is the same as the ratio of perimeter. It's the same thing. But if I want it for areas, instead of 1 to 2, I'd have to square 1 and I'd have to square 2. So it's close. It's not times 2, but we're going to raise it to the second power. And our volume is we would raise it to the third power. So for example, if I said our scale factor was 2/3, and I said, what's the ratio of the perimeters? You would say 2/3. But if I wanted to know the area ratio, I'm not going to say 2/3 anymore. I have to take that 2/3 and square it. So 2/3 squared is really going to be 4/9. Just in case you can't see that, I'll zoom in for a second. And if I wanted to talk about volume ratio, I have to take that 2/3 and cube it. And now I get 2 times 2 times 2, which is 8. 3 times 3 times 3, which would be 27. So it would be these guys that would be our ratios. So perimeters stay the same. Area ratio, we have to square it. Volume, we have to cube it in order to make it happen. Now again, those are just those side notes that I talked about that again, it kind of reminds us what we're looking at, but kind of gives us the opportunity to review as we go through. So those are the first 4 questions. I'm going to zoom back out here so that we can, oops, that was the wrong direction. And again, as we switch pages, I will reassure you that everything will be scanned in and loaded to Google Classroom so that you can go through and practice these. So the next one that we're going to look at is simply remembering, are they similar? And if we remember that there are only 3 similarity triangle theorems. Oops. We have angle similarity, we have side similarity, and we have side angle side similarity. There are only 3. So we don't have to worry about, guessing too many, like with our congruent ones, we had to figure out if there were out of 5 of them, what they were. And we did talk already that with similarity, we have this option where you can guess and pretty much you'll probably be correct. So the first part of the question says, are they similar? So that's a yes or no. But in order to say yes or no, you have to be able to back up how. We did talk about if you're guessing, if you don't see any numbers anywhere around this, it is typically going to be angle. Now, of course, it could be no, they're not similar. There's not enough information. But it's pretty much either yes or no, and then angle if you don't see any numbers. When we look over here at part B, again, we have to answer yes or no. But when I look at this, I got a ton of numbers all the way around here. So what this typically is telling me is if I want to say it's a yes, I'm probably going to say it's by side. Now, granted, if I say no, I have to be able to say that it's missing something. So it's either a yes or a no, and then one of these 3. So in part A, when I look at this, I want to know, do we want to say if this is a yes or a no, and if so, how? Well, you tell me, is it yes or no? And then for that matter, if anybody wants to jump in and tell me what part B is, if it's yes or no, and then tell me how. All right, so let's take a look. So in part A, we've got a no, it's not. I've got possibly someone else who said yes. So let's just talk about what we see in the picture. We don't see any numbers, so it's probably going to be, if it is a yes, it's got to be angle, angle. So the first thing that I want to look at is these are obviously connected right here, and we are going to remember that all vertical angles are congruent. So we have one pair of corresponding angles that are congruent. Then what I've got to do is I've got to pay attention that in part A, we've got these guys. Those parallel tick marks are huge. They are probably going to, without a doubt, end up being a yes because of those parallels. So I do see Morgan did say yes because we have the vertical angles and it's parallel. So when it's parallel, you're absolutely correct. We have to remember that we have in almost every one of these crisscross bow tie situations, you end up with alternate interior angles. And you only need two, but we end up seeing very quickly all three are going to be congruent. So yeah, we end up with our alternate interior angles and our vertical angles. So this is a yes by angle, angle similarity. Done. So yeah, be very careful, make sure. And again, angle, angle, you only need two of them. So we could have said the one pair of alternate interior, the other pair of alternate interior, done. We don't need anything else. Yes by angle, angle. We could use the vertical in one of the alternate interiors. Yep, done. All good, angle, angle. So now the second one we're looking at, and I have a yes. So here's what we've got to be careful of. The issue is, and of course we could always play this, and I will tell you I've done this in the past where we see 1.5 to 3, 2 to 4, and we get really caught up in this 1 to 2 relationship. So then of course to play a really mean joke, not a joke, but a really mean trick, I would put a 5 here. And we see 1 to 2, 1 to 2, 1 to 2, and everybody goes, yes, they're similar because of side, 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 and they walk away. You have to be very careful. What we need to do in this case is remember that we have to separate our triangles. We have this small one up here that's 1.5, 3 1/3, and 2. Then we have this long piece, this big triangle, which here is 4.5, because 1.5 and 3 add up to 4.5. 2 and 4 add up to 6, and this guy down here is 10. So we do have this setup where it's the small triangle and the big triangle. Now we have to compare. So what we want to check is 1.5 to 4.5. Is that the same as 3 1/3 to 10? Is that the same as 2 to 6? Now I can go directly to my calculator and I can check, is 1.5 divided by 4.5, and we can see that that's that repeating 3s, and again we can push this second button and that F to D button and change that to a fraction if we don't have it memorized already, and we found out that guy was 1/3. I can do this one, 3 ABC1, ABC3, close those parentheses, divided by 10, and it gives me the fraction 1/3, so now we're on a roll. And if I can't reduce whatever that fraction is, which I am certain most of us can, but I can put it in my calculator with that 2ABC6 and push enter, and it reduces it for me, and I end up with 1/3. So what I just found out is it does check. All three sets of corresponding sides are in proportion. So my answer is yes, by side, side, side similarity. Now again, your check may be, hey Donovan, your check may be a lot faster than this, but again, this is why it's happening. So again, just a review. Now, just like on that other sheet where we did, look here, where 3 to 9, 4 to 12 did both reduce to 1/3, so got us our parallel lines. What we should also consider is we should be able to tell that it is similar because 1.5 to 3 is a 1 to 2. 2 to 4 is a 1 to 2. That automatically will make these parallel. So a yes is something we should have come by pretty quickly if we can see that happening fast enough. It's just now, what's the fastest way to answer this given the information that we have? Well, it would have been side, side, side. So how triangles are similar, make sure that we look over that information from our notes. If you've been taking notes the way you should be pretty good. If you've completed the no reassignments as they were assigned, you guys are right on track. Again, no new information. We're just reviewing what we had before spring break so that we have it under control before we move into the test for the chapter. All right, so we had the section where I said when we look at our equivalent proportions, we want to make sure that we're matching patterns. So in this problem, you can see our multiple parallel lines are cutting transversals. And as they cut the transversals, they're going to break them up proportionally, which means this ratio should equal this ratio. This ratio should equal this ratio. And we match the patterns. So as you think you know what the answer is, what I'm supposed to fill into each of those blanks, type it in the chat section. Good. So you are correct. AB over BC, so top, bottom, should match top, bottom. So we do have X, Y here. Nice job, everyone. And then if I want to talk about the next one, AC over something would be the same as BC over YZ. So we went side to side. And you are correct. Nice job, Caitlin. We do have XZ. That's all. I'm not asking us to use it. I'm not asking us to do anything. I am just asking us to fill in the blanks. So last but not least, and then we are done for the day, is just our angle bisector theorem, making sure that we remember how to set that up. So I'm going to pause. I'm going to let you try to figure that out. And when you think you have an answer, please type it into the browser. I'm not going to set anything up. I'm not going to talk about it. Just remind you that this is our angle bisector theorem. And let me know what you believe X is. All right, I agree. It is 7.2. So when I set these up and I don't have to plug anything in or fit anything in, I always do the side of the angle to the side of the angle, so 20 to 16, and then I hold that same pattern to the side that's been divided by our bisector, so 9 to x. I go the same pattern, left to right, left to right. When we cross multiply, we do get 20x equals 144. And then when we divide both sides by 20, you end up with x equals 7.2. Now again, you're going to write your answer, but most of us still don't consider the fact that 7.2 might not be how we want the answer written. So don't forget that the absolute way to get accustomed to writing all of our answers would be in fraction form. And a lot of us got caught up on the no reassignments with, yeah, we got the decimal correct, but it wasn't accepting the decimal answer. Because our fractions, especially when we have to round off our answers, the fractions are what's better because that's the exact value answer. So something like 17 over 31, we would have to round that decimal, but 17/31 would be absolutely what would go in the in the answer. So don't be surprised that, again, we've talked about fractions all year, and this was the first chapter where you were actually held truly accountable for it. So 7.2 and 7 1/5 are the same thing. So with that being said, those questions ridiculously come close to many that you're going to see in your assessment for the chapter. You are going to find these questions and their answers, as well as a blank copy of this so that you don't see the answers as you're practicing, and then you can check your own answers later. So I did want to make sure that you have all of that. I will post that to Google Classroom. You will also see that I will post your test for the chapter as well as the due date, and you will see all of that in Google Classroom. So the good thing is right now there's no homework per se. There is nothing else that you will be working on this week other than the test. So please look for Google Classroom updates, and you guys should be then pretty much done for the week. Wednesday, if we come back, I will answer any questions that you have. It should be a pretty short session, and then we will conclude the week, and I will make sure you know what your due date is. Again, check Google Classroom. Every email I send back to students, I simply say, have you read Google Classroom? So just make sure if you have any questions, email me, but check Google Classroom. All right, guys, I will talk to you again on Wednesday, and I'll say it for the 100th time. Make sure you continue to check Google Classroom. Outside of that, really miss being in the classroom with you guys. Talk to you Wednesday.